Greetings, welcome back to Black Bear News. Yes, Basil Peterson. Today's beginning resembles yesterday's end. Welcome back to Black Bear News, where everything is connected. I have no idea what happened to the end of the show yesterday. I apologize for that. For people who want to view on Rockfin, we are live on Rockfin right now. I tried everything to get my stream back going. Apparently, they just didn't really like my subject matter, or they or something. NSAG Demarest, yeah. Or I don't know. I don't know what was going on. You can be conspiratorial about it if you want. That might be true or not, but whatever happened, I apologize. So, thank you guys for joining me in the discussion yesterday around global dimming. I know that, my take can be somewhat controversial. I've talked about this before. This isn't a new subject on this channel. And yes, my headline was a little bit hyperbolic, I guess, or maybe just a little trying to poke the beehive a little with the stick. I don't think that global dimming as a concept is bunk, as in not true at all. I just think that's fine, Rich Diana. I'm just trying to brighten up your day. You know what I'm saying? I just think, well, from observation, just cursory observation from the pandemic, whatever was supposed to go on with global dimming, with a large downturn in emissions, it didn't happen. That doesn't mean that there couldn't be, some minor effects of global dimming, in the system, or contributing to the heating that we're seeing this year. Of course, there are quite a few climate change related events that are happening this year that speak to the fact that climate change is progressing, is getting worse. Is the things that we are seeing are not good signs of not good things to come. So, and maybe a part of that is global dimming, or a small fraction of that is global dimming. But as far as the huge alteration in temperatures, or the huge spike in temperatures that were supposed to happen due to the lack of dimming, it just didn't happen. So, and that's just a fact. That's just, you can't really, I know people want to throw up all the things, but the fact is we didn't see this gigantic major spike in temperatures. We saw temperatures go up regionally. We saw extreme weather events go up. We saw, all kinds of things happen that we've been seeing happen for the last 4 or 5 years. That's all I'm trying to say. And the reason, the upshot of all of that, and just to quickly, we're going to talk more about global dimming. I'm going to get a little deeper into it because it deserves more attention, I think. And I'd like to, I'm trying to bring in other views around global dimming and what's going on. The upshot is that, the idea that we can't take definitive action or reduce emissions because we're going to burn ourselves off the planet due to global dimming, I think is, that idea has lessened dramatically due to the events of 2020. That's all I'm trying to say. So I think we should go forth and go forward with right action. We should go forth and go forward as quickly as possible into a new world, or a new way of living, or a new way of being, or a different way of living, or a different way of being. That's all I'm saying. Yes, Kuro hikes, but global dimming or not, if you're saying that to shut it down, I'm down. Yes, shut it down. Global dimming or not. Even with the prospect of global dimming, I always thought that we should just go ahead and go forward anyways. Do the right thing anyways. Do our very best. And you never know. There's so, again, and I said this yesterday and I'll bring it up again. Climate change is an extremely complicated issue. There are a lot of factors involved. The Earth systems are extremely complicated. There are so many factors, so many things going on, so many, not just positive feedbacks, but negative feedbacks, which global dimming is a negative feedback in the short term, right? It's so complicated. If we lower emissions or just go forth and lower emissions or try to turn off the tap of fossil fuels, we don't know. We actually have no idea whatsoever the exact consequences of turning off said tap. We have no idea. We don't know what's going to happen. We could see a sudden spike in temperatures and, burn ourselves off the planet, or, the Earth could conspire along with us and say like, oh, thanks a lot. Thanks so much for that, that respite from the onslaught of destruction that you guys are bringing onto us. Let me give you a little reprieve here so you guys can work your shit out. But, the problem is, of course, is that humans are not looking like they're ready to make a full-on commitment to doing, the things that need to be done. So there you go. Lots of ins, lots of outs, says the dude. New shit has come to light, man. Exactly, the dude. To quote Duncan McCown, I agree on dimming. I've changed my mind as well. Beckwith was an early spotter. That effect was less prevalent than some have predicted. So, and I'm not saying this to debunk anybody or to call anybody's science into question. Not at all. Like I fully accept the concept of global dimming, and I fully accepted the concept that it could be something. Just another, brick in the wall of the insurmountable wall of climate change, But I'm saying this as, I'm saying this in light of the evidence in a way to say to people, rejoice, rejoice, because there is some silver lining in all the darkness. The other thing we could rejoice about is look how consequentially we lowered emissions when we all decided to do something. It wasn't as difficult as we all thought it was. It can be done. We were given a roadmap. We were shown the way. Rejoice. Poppy Davis, sort your shit, humans. Exactly. So we're already super late, so I'm going to dive into this. Right. Ecocentric homestead. Problem is humans enjoy the smash and grab principle. They just take what they want and to hell with the consequences. Yeah, and we are still there. We are here. Yeah. Kuro hikes the way climate change is working. We're never going to know if dimming effect matters or not. Yes. Anyways, I had a lot of good responses yesterday. I mean, there was a lot of good conversation around, and that's why I did the video, is to get the conversation going, or to just bring in another idea to talk about. So, that's all. Let's go into it. So quite a few people linked this article to phys.org, which I don't think that I saw. Bad on me. But this is a great article about what happened to global dimming during the lockdowns. So this is from October 22nd, 2020. Why lockdown had little to no effect on global temperatures. Countries across the world took unprecedented action in the first few months of 2020 to control the spread of COVID-19. At its peak, 1/3 of the world's population was in lockdown around the world. Car travel fell by 50%. The number of flights plummeted by 75%. Actually, that's probably a global number, but more than that in the U.S., like in some places up to 90%. And industrial activity fell by around 35%. Significant. With so many cars parked, airplanes grounded, and factories closed, global carbon dioxide emissions fell by around 17% compared with the same period in 2019. 17% is significant. More than we have done as, a collective in when? Since the beginning of the Industrial Revolution. But greenhouse gases such as CO2 weren't the only emissions to fall. And not all pollution heats the planet. Some of the industrial activities that shut down, particularly heavy industry, including steel and cement making, also produced aerosols, which are tiny particles that linger in the atmosphere for weeks and reflect heat from the sun. Previous studies have suggested that if a lot of these industrial processes were to suddenly shut down, it would lead to short-term warming because the atmosphere would lose the reflective effect of aerosols. But as the lockdown cleared skies, temperatures didn't rocket. So that's, just what happened. By all measurements, this spike that was supposed to happen did not happen. So what really happened? Climate and chemistry. Sulfur dioxide gas is mainly produced in industrial processes that burn coal. In the atmosphere, it reacts to form white sulfate aerosols. These particulates or particles offset some of the heating caused by greenhouse gases such as CO2 by reflecting sunlight back into space. Obviously, this is the material they want to use for SRM, or mentioned in the talk of SRM, or solar radiation management, SO2. Reflecting sunlight back into space in a process known as global dimming. If SO2 were the only pollutant whose emissions fell, we would expect Earth's temperature to increase. Soot, otherwise known as black carbon, is also made when burning dirty fuels and emitted in large quantities from older cars. Since soot is black, it absorbs sunlight and heats the atmosphere. Cars and airplanes also emit lots of nitrogen oxides, or NOx, gases that make ozone in the lower atmosphere, where it acts as a greenhouse gas that warms the planet. Satellite images in March and April showed huge reductions in NOx over Europe as national lockdowns came into force. The different gases and aerosols we emit either contribute to global heating or global dimming. So they either have a cooling or a heating. So determining how lockdown affected global temperatures is a matter of finding out which effect dominated. We ran a series of computer model simulations of the atmosphere during lockdown versus what we would have expected if the pandemic had never happened. We fed into the model the best estimates of how much emissions of SO2, black carbon, and NOx fell from industry, transport, and aircraft for the period between mid-February and mid-June. Our model simulation showed that reductions of these different pollutants only had a small and temporary influence on climate overall, in part due to their opposing effects. This may sound like a dull conclusion, but it has important lessons. 1 second, guys. missed it, guys. Sorry about that. Please let me know if you can hear me. I'm sorry. Ha. 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 For whatever reason, it wouldn't... I'm not ignoring you. I was wondering... I thought there might be a change in the sound because I did something different. Apologize. Okay, we're going to go back. Quickly go back, okay? Let me go back to where I was before the sound was off. Our model simulations showed that reductions of these different pollutants only had a small and temporary influence on the climate, overall in part due to their opposing effects. This may sound like a dull conclusion, but it has important lessons. Which sectors were affected most was hugely important. The largest emissions reductions were in transport, where NOx and black carbon emissions are particularly high. This largely offset any heating that would otherwise have occurred from the drop in SO2 caused by the slowdown in heavy industry. A global average temperature saw little change, but there were regional variations. For example, the Middle East was cooler since less black carbon in the air meant the highly reflective desert sand could send more solar energy back out to space. All right, cool. So the largest emissions reductions were in transport, where NOx and black carbon emissions are particularly high. This largely offset any heating that would otherwise have occurred from the drop in SO2. Okay, so I read that. Other regions such as Eastern China saw more heating overall as they had some largest reductions in industrial SO2 emissions. These differences in heating patterns could affect weather systems. What we've described here are model simulations. They're not perfect, but they're our best method for investigating global atmospheric changes. I apologize for the difficulties in the sound, guys. I don't know why. Simulating the effects of all these different pollutants is difficult. In fact, the struggle to simulate how aerosols affect the climate is one reason we cannot predict exactly how hot the climate will get. So, you know, there are lots of models and predictions, but we actually don't know. There are a lot of variables, right? We don't know. We all know that, we all know the timelines and the trend lines and the timelines and, the scale of heating and destruction we are doing. We all know where that is leading. We just don't know the exact day. We don't know the exact hour. We don't know exactly how the Earth is going to respond to anything that we do, whether we do the right thing or do the wrong thing. But best guesses are probably mostly accurate. The lockdown offered an invaluable test for our theories about how pollutants affect the climate. From this, we'll be able to improve our models and make better predictions. We'll also know better how to plan a strategy that reduces emissions from different sectors without inviting a sudden and sharp increase in global heating. Wow, so we could probably coordinate ourselves, you're saying? If we could actually coordinate ourselves as a collective, as a human collective, if we could coordinate ourselves to reduce emissions, then we might possibly coordinate ourselves to do it in a way that wouldn't destroy us in the process. Well, sure, why not? If we're gonna go out on a limb, if we're gonna go reach out to the possibilities, the post-pandemic climate, the long-term effects of the pandemic on our climate will be determined more by what happens to long-lived greenhouse gases such as CO2 and methane. Those remain in the atmosphere for centuries and decades, respectively, compared to a few days, 2 weeks for NOx, SO2, and black carbon. CO2 emissions dropped during lockdown, but not enough to stop levels in the atmosphere growing. Global heating won't stop until emissions reach zero. It may seem daunting that the near shutdown of society didn't cause a big enough reduction in emissions to stop climate change. But this just shows the limits of doing... Well, so this is where they get a little weird here. This just shows the limits of doing less of the stuff we normally do. Actually, it shows the power. Wrong. It shows the power. 17% reduction in emissions. More than we ever dreamed that we could do on a when we talk about gradually reducing emissions over the next 10 years or 20 years. We're always talking about 5% or maybe even 10%, 15% a year. I mean, we did 17% whammo. So wrong. It shows the power of doing less of the stuff we normally do. And if we couple that, they're saying instead of changing how our economies and infrastructure are powered. Okay, again, wrong. We don't need to change how we're powered. We need to stop powering, period. Stop the powering. Lessen the power, period. The end. Not change. So they just go off the rails here a little bit about the actual things that we possibly could do or should do. While lockdown measures have brought temporary reductions in emissions, there are better ways of doing this that cause less harm to society and people. Okay, it's not about people all the time and society. Maybe people in society, maybe we should humble ourselves and do a little less of, ourselvesing. I don't wish to harm people, but maybe we could just tell people that, look, you just don't get to do all the things that you think you get to do, because nature says so. Mother Nature is going to come in and give you a talking to, and you're going to do what Mother Nature tells you to do, or else. And that's pretty much true. Only a decisive shift from fossil fuels will stabilize global temperatures. That's why decisions governments take to revive economic growth after COVID-19 will be pivotal. Just a bunch of neoliberal blobbity blue after this, so whatever. We've got to have the recovery centered around a green renewable technology and not fossil fuels. Okay, sure. Okay, fine. Awesome. Thanks for coming back, guys. Sorry about the earlier sound issues. Let's move on. I want to quickly cover some other things before I have to go. We're already deep into the time. I started late, so I'm going to try and go quickly. Let's move on to this article from climatetippingpoints.info. And this is fairly long, so I don't know if I'm going to read the whole thing, but I just kind of want to get into it a little bit. Fact check: is global dimming shielding us from catastrophe? So fact check: is global dimming shielding us from catastrophe? Claim: global dimming due to cooling by aerosols as opposed to global warming from greenhouse gases is masking a large amount of warming, 0.7 to 1.5 C. So if we stop carbon emissions now, we'd get a catastrophic jump in global warming. Reality, this is what they're saying. I'm just reading this, guys. Reality, global dimming is masking around 0.6 C of anthropogenic warming. There are many aerosol sources, including some that cause warming, and so shutting down the worst carbon emitters like coal power stations would not lead to all aerosols disappearing immediately or sudden dramatic warming. True. So we just read in the last article, there are different particles and gases in the air cause different things to happen. So yeah, some of the things we shut down would actually lessen the warming, right? So it has been claimed that humans, like airplanes and cars, right? It has been claimed that if humans reduce carbon emissions now, we'd actually end up causing a rapid jump in warming as a result of something called global dimming. This has been posed as an unavoidable paradox, as by closing high emitters like coal-fired power stations in order to reduce greenhouse gas emissions, we'd end up increasing temperatures anyway through global dimming, potentially passing dangerous Info's new fact-check series. We investigate how much warming global dimming is shielding us from. This is an interesting topic, guys, and I may even have to come back tomorrow and do a little more on this, because somebody else tweeted something very interesting to me. I don't even know if I'm going to get a chance to get into that. Something that James Hansen has claimed, that we have been experiencing a drop in global dimming or aerosol masking for 5 years, which is another, pretty substantial claim and a substantial idea. Removing the mask, global dimming is the opposite of global warming, with tiny particles we emit called aerosols scattering away incoming solar energy and so cause cooling. as opposed to greenhouse gases, which trap heat and cause warming. They also affect cloud formation, impacting on how much heat those clouds either trap or reflect. Human aerosol sources, including sulfate from burning fossil fuels like coal soot from factories or wood burning, and dust from roads and land degradation. Natural sources of aerosols include deserts, trees, sea salt, and volcanoes. Before clean air laws were introduced in the 1970s and 80s, aerosols may have balanced out warming from carbon emissions and contributed to relatively stable temperatures in the 1950s to the 1980s, but this effect has been declining since the 1990s, right? And this is partly goes along with what James Hansen is claiming. It also has, been suggested there was a 1C warming jump in the days following the September 11th attacks when planes in the U.S. were grounded for a few days, and that this implies a large amount of warming is masked by airplanes alone. I talked about this yesterday. In recent decades, though, greenhouse gas emissions have continued to grow, while aerosol emissions have declined as clean air laws have kicked in. And so overall, we have a net global warming. Good old-fashioned global warming. Global heating, if you will. The graph below shows all the factors driving global warming and cooling. In terms of global radiative forcing, RF, that the actual human-driven energy imbalance that leads to temperature change, measured in watts per square meter of Earth's surface, leading to overall warming effect summed up at the bottom. It's a nice little graph. Let's see if we can, view this a little larger. So the radiative forcing by emissions and drivers, so CO2, CH4, halocarbons, N2O, CO, NMVOC, and NOx, aerosols and precursors. So here's the looks like cooling, the cooling effect of some of these NOx, aerosols and precursors, mineral dust, SO2 and H, and organic carbon and black carbon. Albedo change due to land use. Also causes some cooling, changes in solar radiation or irradiance, also some warming. So total anthropogenic radiative forcing relative to 1750. Watts per square meter, or yeah. So to 2011, we have 2.29. Up to 1980, 0.57, up to 1950, 0.57, 1980, 1.25, 2011, 2.29. It's quite a bit more. Let's see if we can go back. You can see from the graph above that despite the far larger greenhouse forcing, there's still a fair bit of global warming being masked by aerosols. Doing the sums from these figures, the overall combined effect of aerosols, including indirect cloud effect on RF, is around negative 0.8 watts per square meter, which, if totally removed and without counting for feedbacks, would be equivalent a decade or so, and up to 0.6 C longer term. So, fairly significant amount of warming, but they're not saying like immediate within a decade. This also fits, it's pretty fast. This also fits with sources of the observed warming so far, with a net non-greenhouse gas forcing of negative 0.25 C for 1950-2010 versus negative 0.34 C for the same gases now on the graph above. As its radiative forcing changing rather than temperature, as with CO2-driven warming, there'd be a bit of a lag before temperature catches up. A couple of recent studies have also suggested that the indirect cloud effects might be towards the greater end of the IPCC range of around minus 1 watts per square meter, boosting the total aerosol effect to minus 1.3 watts per square meter. But the associated cloud dynamics remain highly uncertain. And I would like to see more information around clouds created by jet contrails. I'd have to say that's probably fairly large. And kind of a weird gray area to talk about. We can also look at natural case study of impacts of rapid change in atmospheric aerosol content. The Mount Pinatubo eruption in 1998. This eruption injected huge amounts of sulfate aerosols into the stratosphere. And I guess we could count wildfire soot and particulates as well, right? We've had an increase of that and led to a global cooling of 0.5 C peaking within 1 to 2 years before the sulfate aerosols began to decay. In effect, this is the reverse of our scenario of a shutdown in anthropogenic aerosol emissions, with aerosols rapidly added rather than removed. However, the peak global RF change was a very large negative 3.5 watts per square meter, which, if it were sustained over a decade or so, would have led to an even greater cooling of 1.7 C over a century. This shows how a rapid change in global RF from changes in aerosol content still takes a while to drive a change in global surface temperatures, with only 20% of the total potential impact occurring within a year, 60% in around 10 years. It's also important to note that this is the global RF and temperature change. A drop in regional aerosol emissions would have a more rapid regional impact, but it takes longer for the whole of the global climate system to catch up. And I'm sure we have in the past and also in 2020 seen some regional changes in temperature due to lack of global dimming. I'm sure there's some of that going on for sure. So the 0.7 C quoted at the start of this article is not too far off our estimate here of an eventual warming of 0.6 C, and it fits with other studies too. However, larger masking effects are sometimes claimed. One model study has projected up to 1 C warming resulting from strong aerosol emission cuts, but this represents what would be masked by 2100 after continued moderate CO2 emissions rather than what is being masked now. An even higher figure of 2.5 C is also sometimes claimed. This is hard to reconcile with observed RFs and heat budgets. This figure is also based on just one model with an estimate for the strength of aerosol cloud feedbacks far outside the range of other model and observations. The big difference between aerosols and greenhouse gases, though, hold on one second. I'm going to just check in with y'all, make sure everything is not off the rails. Keith Hayes says this is basic science. ERC1, cloud dynamics, indeed. Gray Stash says what will happen when we get into the solar maximum, a boiled planet, all right, and or what happens in the next El Nino. I shudder to think. All right, just very quickly, I'm going to read a few more paragraphs of this, guys. The big difference between aerosols and greenhouse gases, though, is that aerosols have a very short lifespan in the atmosphere, falling out of the atmosphere after only a few weeks. This is why if we engaged in solar radiation management, SRM, we would have to do it continuously to keep the planet cool. That's why a lot of people think it's a bad idea. This has led to the fear that shutting down heavy carbon emitters like coal power stations as part of decarbonization would lead to a rapid warming spike as all the aerosols disappear, risking passing imminent climate tipping points. This scenario is sometimes called the dimming paradox or the McPherson paradox, after one well-known and controversial proponent. But human-made aerosols have many sources, from power plants to cars, fires, and agriculture. An immediate removal of human-made aerosols over only a few years is extremely unlikely. Right, that's extremely unlikely. With decarbonization likely taking decades. That's, yeah. We're moving at a snail's pace, by the way. We did the most this year, and we did it accidentally. It's also worth remembering that most aerosols, such as black carbon from incomplete burning and smog and brown clouds, actually cause warming as well by absorbing some incoming solar energy rather than scattering it. Right. Some of these particulates, they warm and they cool at the same time. So if they cancel themselves out if we get rid of them. And so driving down aerosol emissions from industrial smog would reduce a source of warming as well as cooling. Again, one of the main reasons why I think it is, our best bet is to go forth and do our utmost in the reduction of the things that we are doing to kill the planet. We should do all of that as quickly as possible. Consequences be damned. Dimming be damned. As a result, any warming from aerosol reduction would be more gradual and partial than portrayed in the dimming paradox scenario. Even if an immediate phase out of aerosols along with CO2 happened, more realistic modeling for the 2018 IPCC special report on 1.5C showed the actual aerosol warming bump would be at most a temporary 0.2C warming after a decade. Okay, I'm going to have to wrap it up, guys. But yes, and this has been borne out, I believe, rightly or wrongly, I believe this has been borne out by what we have seen in a drastic reduction of emissions due to coronavirus. There are many other factors that we have to contend with, though. It's not just the dimming. Obviously, we have warming locked into the system, and we're not really going to get away from that. It's going to be very difficult to get away from that, but maybe that warming that's locked into the system, who knows how long we have, guys. Honestly, we all know what's happening. We all know what's happening with the Arctic ice and eventually the Antarctic ice. And we've already pushed some tipping points, feedback loops into play that are going to be very difficult to stop if we're going to be able to stop them at all. And Osama brings up the really good point of what do we do? What do we do about all these reactors? What do we do about all these nuclear reactors? Funny. Interglacial optimist. We should try some credit default carbon swaps. Hilarious. No, let's not do that. Let's not do that one. So and somebody brought up in the comment section that I was suggesting that we do all kinds of tech utopian solutions like tech fixes and green renew. I don't suggest that at all. I'm not suggesting that. And I've never been a huge proponent of the green fixing or the renewables fixing. I'm not a proponent. Also not a proponent of carbon swaps or carbon pricing. I think is a ridiculous solution or concept, but whatever. Some people think, it's all the rage in some people's minds, whatever. Anyways, guys, I have run out of time, and thank you all for joining me. Thank you for your eyes, your ears, and your conscience. This is a continuing conversation, right? This is something that is ongoing. This is an ongoing, slow-moving, then sometimes quickly, sometimes slowly, slow-moving, but also fast-moving disaster that we're watching in real time, and we have a little time to talk about it, so we're going to do that some more tomorrow at 11 a.m. Pacific Standard Time. Osama says, as an engineer, tech solutions are interesting to me, and there will be many. There will be more. There will be many to think about, to contemplate. Even Guy McPherson has contemplated the mirrors in the ocean solution, which he thinks might be the best of the ideas. So, and we're going to, somebody's going to contemplate them. So if we don't contemplate them, I don't know. I think that it's a good idea to discuss. Anyways, guys, until tomorrow, peace.